I thought I would focus on the innovations at RCAC. And there are so many things we do at Rosen Center for Advanced Computing at Purdue. And I'm only going to highlight a couple of things. And today I'm going to focus on computing and people. So first up is for computing, I'd like to talk a little bit about Anvil. Last year, I gave a more detailed presentation on what Anvil is, how we built it, how people are using it. I'm going to do just a little bit recap, just for those of you who are not familiar with Anvil. So this is our National Science Foundation funded large capacity computing system for the whole country. So it's not just Purdue. Preston talked about the community cluster program for Purdue. We have multiple clusters, and this is a large one that's funded by NSF. And we partner with Dell primarily and with other vendors, including NVIDIA, AMD, NVIDIA, and DDN. And it was built during the pandemic, during 2021. And we began operating it in production fashion in early 2022. So I can look at here. And so we're in the second year of operations to support users from around the country to conduct their science and data-driven analysis here on Anvil. So we like to use this chart, so you should memorize the 4-quadrant, if nothing else. So Anvil has several components. One is capacity, so it has a lot of CPUs, 1,000 nodes, and each node has 128 cores of the 3rd generation AMD processor. And the second component is software ecosystem that makes it run, makes it useful for users. And the third component is the composable. So these are new things we're trying as part of a supercomputing ecosystem, which I'll get into a little bit more detail later. And of course, the fourth one it's the last one, but not the least, is training to educate next generation researchers and workforce on using these advanced computing resources. And you can find all the information about Anvil on the site there. And so showing a few pictures, and what I like to say is, obviously Anvil is composed of, various components, but when you put them together and with people, it really amplifies what researchers can do on the system. People, here is a picture. I think it's only part of the team at the end of the summer when we celebrated our student program of the summer. And you can see the wiring, the cooling, the processor, the board, all of that. And here's something we're really proud of. So we just updated this for this year. And so these numbers are the primary metrics. We have a lot more numbers. Here you can see that we make allocation for researchers around the country. So it's about more than 800 million units or CPU hours allocated. So those are the numbers we make available to researchers in the country. And over the throughout our operations, we have more than 4,200 users. These are faculty members, a lot of graduate students, postdocs, and professionals. And they're all using Anvil to do research in one of the 46 scientific domains. That's a category, those are categories created by National Science Foundation. And this chart also shows that we have a lot of undergrad students using the system. And I'll get to that in a little bit more detail later, how they're using it. So one thing I do want to say, so ENVO is an NSF-funded system. It's part of the NSF computational ecosystem, now called Access. Before there was the previous program. For those of you who know about it, it was called Exceed. Now it's Access. And so this is a chart I just pulled. It's a quick chart for the past months. And basically, this shows the kind of the top systems in this ecosystem and how they're being used by the user. So the red area represent the usage of ENVO CPU nodes. And there are also GPU usage on the bottom, but in terms of number of hours, they're kind of small. No, this just shows the CPU hours. Okay. So normally we would talk about a lot of science use cases. Because of time constraints, I'm going to skip those, but just to say that this is an illustration of how what's the science being conducted on ENVO. So from anywhere from tracking breeding trend of the endangered species, such as golden eagle, from the eBird project. A lot of us probably are familiar because we use apps created by the eBird project, and to other, for example, the hypersonic shockwave studies, and to using machine learning, studying machine learning algorithms to improve visual perception and materials research. So I'm not going to go into details because I got a lot of other things to talk about. So going into, what are the innovations on ENVO? So we have a large system. We can accommodate a lot of applications, a lot of users. But the innovations comes from really thinking about people, how users are going to use it. How can we lower the barriers? So when people hear about parallel computing, high performance computing, they think about Linux, command lines. A lot of students and researchers are not there yet. So can we help them to use the system by lowering barriers? One of the ways is to make it interactive. So to ease the transition from running on your laptop to running on a supercomputer. So some of the tools we have there, if you want to use it but don't know how to access ENVO, you can see that there are a lot of the interactive applications that's available through your web browser, such as Jupyter, such as RStudio, and through this open source interactive computing environment called Open on Demand. And there's also the remote desktop tools, ThinLink, that you can use, and you can see the available interactive applications. You can start there. So without the users actually knowing command lines, they're actually running on the supercomputer. So a couple of quick examples. So we were really proud that this was the second year we support the Big Care workshop. These are bioinformatics researchers. A lot of them had no experience with supercomputers, with command lines, with Linux. They all gathered together at Purdue and to use ENVO is the backbone for them. All they see is their notebooks, their algorithms, their tools that's available for them during the workshop, and then they can continue to use it afterwards. So we're really proud that these professionals and students, they had great experience using the resource throughout the learning, and we're going to continue to support them next year. The other example shows that a system like this can be used by students, even undergrad students. So I remember a year ago, we tried to onboard 1,300 undergrad students onto the system, which was a feat in itself. And we had a great team to help them work with the students. So this is the project led by Professor Mark Ward in the Indiana and National Data Mine program. This is a program, a data science program that provides students with experiential learning. So they learn the fundamentals of data science, and then they are paired up with real world projects with companies, with other institutes. And personally, I have a project with Illinois and many other institutions, and we actually started partnering with the data mine program to get students from that program to work with us on data-driven scientific applications. So again, Envo proved that 1,300 students, it sounds pretty scary if you ask me, but they were able to use it during their semester-long projects, and they continue to use it. I know that we, according to tickets and stuff, I know they're still using it. So that's a great application for a system this big. We have no worries about running out of nodes for them. And it also helped them to manage large data sets because the large storage system that comes with the supercomputer. And let's see. So another innovation that I want to bring up is the integration with clouds. So traditionally, you have supercomputers, you have cloud computing. They're totally separate. So what's the role of cloud computing in this ecosystem? So one idea we had when we wrote the proposal was that we really want to bring them closer together, ideally to be able to work together in the sense that if you have too much work on the supercomputer, you can kind of burst them out into cloud instances, HPC instances, or for our composable system, which is like a local cloud. And if there's too much work there, or if there are resources that applications needs that we don't have in our composable system, we can send the workload to commercial cloud, for example, Azure. We have ongoing collaboration with Azure, and that's why we included this work. And I'll highlight some of the work that our students have worked on in this summer towards these goals. So the third piece that I want to mention as an innovation on Envo is the composable subsystem, which is a Kubernetes-based system where it's very different from your traditional batch-oriented supercomputing system. So these are sort of your cloud right next to your supercomputer. There are lots of applications. I listed some. And most of all, it's designed to be easy to use. For example, one of our projects was supporting a summer school training students and researchers to use geospatial models and tools. And we found us in a situation where we had to quickly pivot to deploy Jupyter Hub on Envo, which I thought I was not there on site, and I thought that would be very, very hard. But turns out, it was done within an hour, and the training went on as usual. And later, I heard from faculty saying, we had no issue with scaling up, supporting 30 students all running their stuff at the same time. So these are the sort of the applications, notebooks, the research notebooks that captures the entire workflow of a research project that I put in here. So these are the things you can do with composables, and I feel there's a lot more potential that we could leverage systems. For example, if you run your big simulations on the supercomputers, the output can be explored by other people, and rather than taking it somewhere else, this is a really easy way for you to also have your data exploration applications there available for public access. So there's another area of innovations that we've done in the past year, and this is done by our scientific applications group. And I want to just highlight, I know they've done a lot of things, and really I want to give a shout out to the group that I picked a few just for convenience, for the graphics that I already have. And so, for example, we curated more than 800 biocontainers. So these are bioinformatics applications that have been containerized for people to run really easily. So all the software dependencies are taken care of, all packaged up. And we have proven that when users use these containers, they can get up to speed and run very quickly. So, I don't know how many users we have. I asked around and I put an estimate there, so maybe there are more users, or we'll find out later. But so these are great tools for bioinformatics researchers, and we do have training for these newer things that we're doing. So if you go to the RCAC webpage, you see training calendars, and check out those that you're interested in. So one thing I want to point out is that these biocontainers come from different sources. I think some come from Docker Hub, some are homemade by our staff, and there are also biocontainer repositories. So, and this work was done by our staff listed down there. And another application that I'm learning today at the poster session, because I don't use this application myself. So CryoSpark is for constructing 3D structures of molecules from 2D images taken by cryogenic electron microscopy. And so this is also the latest work that we've done, and we've made this available. And because the cryo-EM devices are really important and very popular among researchers, and I also heard about the CryoDB, EMDB, whatever. That from today's conversation with students. And so it sounds like this could be a great tool for our the cryo-EM researchers to use to run on Envo really easily. And the other innovation I want to highlight is our upcoming Ticket Hub. I was wondering if I had a typo there. So, so this is really to help us understand better what issues users are having, so that we can better provide services. And so this is hot off the press. I got from our senior scientist, Sarah. And so this graph shows the classification of the topics in our research tickets. So probably intuitively, you can see that this would quickly help us to kind of zero in on what's the most frequent issues. And it can help us diagnose, it can help us design training programs, and and this is very repeatable, right? Using, I think the team used NLP to, and the algorithm to go through the ticket data and present this. And we're hoping that this could become, our one of our regular tools that we use to look at what issues people are running into. And so if you're interested in finding more about Envo or want to use it, we have a lot of documentation. Again, it's a national resource, so you go to this program called Access, NSF Access, to put in your request. Even graduate students can do that. So among our users these days, there are a lot of graduate students who can get their first allocations pretty easily. So, so now so all of that, and also I'm thinking back to earlier presentations. I think several speakers mentioned, people is really important, software is really important, and software is really it's really people who write it and people who designed it. So, so that's kind of my transition to talking about, what does this cyber infrastructure ecosystem look like, right? So if you look at, so this is one that I took from one of our most recent papers when we talk about cyber infrastructure for sustainability science. But this is really a general picture for any field of science, especially for those who involves observational data and analysis, modeling, simulations, and also translating the results into actionable decisions. And so if you look at it, the top two boxes, one says resources, the other says data and software. Software really is the enabling technology, and software is written by people. Well, at least now, right? Before before AI takes over our lives. So on the bottom, it's really about broadening access, democratizing the access to these advanced cyber infrastructure resources so that people can make progress on their research, on teaching students and next generation researchers. So if you look at, from that perspective, it's really, very people heavy. Without people, without software engineers, without people who are familiar with applications, who speaks languages, both cross, domain science and computing, a lot of this would not be possible. And that's why, what I want to do is really talk about the topic of research software engineering. So we have a short acronym for it, RSE. So what is RSE? So this is one of my favorite chart. So if you look at the box, it says, so anybody who has run into this, I'm sure a lot of you have. So if you look at your workflow in your research, you say, well, this part, I do it over and over again. I can just automate this. So now I'm going to start writing a script to automate this. And then you start writing your code. And then in the research process, if you find yourself, just keep revising, keep growing this code. And I would say you probably are touching this area called RSE, Research Software Engineering. And for formal definition, of course, you can search the internet, you can find formal definition. The ones I go to most one is done by a UK group on RSE. They started, I think, first. And then there is a US RSE organization nowadays. And regardless of the words, one is shorter, the other one is more verbose. Try to be inclusive. And I highlighted these words. So essentially it says, if you're doing research and using software or writing software and do that for most of your time as your job, then you're part of this community called research software engineering. And there is a lot of efforts going on to professionalize RSE. I'll mention a few challenges later. So our vision is really, well, first of all, we've been doing this at RCAC for the past, I would say, more than 15 years. Partnering with projects, faculty, students to write software as solutions to their research studies. But it was primarily done in a very ad hoc way, right? So we know people work with us, they spread the word, and we get more people to say, we have this project, can you help me? And so our vision is really to elevate this. I think Preston mentioned this briefly earlier. So really elevate this to the level of a core capability within the university. And I would even go on a limb to say, even beyond Purdue, right? So we're part of RCAC, and I think the way we're organized, we're close to our systems team, we're close to our computational applications team. That just, position us in a very good place to be able to carry out, all these software engineering projects from design, development, and deployment and long-term sustainability. So I listed, a number of these things. I think it's probably, some of them are intuitive. Others are what we're pushing for, really to elevate this capability and increase awareness so that we can help advance Purdue's major initiatives in the future. So I want to just do a little bit of a anatomy of HPC Center. So this is probably not unique to RCAC, but this is what we look like. So we have a systems engineering group which runs the system, operates the hardware, and we have the scientific applications group, which really focus on curating HPC software and providing support. And we have a scientific solutions group, which we primarily develop software-based solutions for research projects. And we also have Innovation Center, which George Takahashi will present this afternoon. He has great graphics and videos. And we have training, we have outreach and communications. So, if I look at this, I highlighted some squares, shapes that, all have RSE elements in. So obviously, scientific solutions and Innovation Center were primarily doing software engineering work, but other places, all have people who are most of their time during the day is doing software engineering. So, it's part of HPC. It's part of the ecosystem, and that's what I want to emphasize. And obviously, when you start this, in a more formalized way, there's some key questions you have to answer. Who are your customers? What is your business model? And what's expected of our RSEs? So these are, things that I thought probably help people to kind of see what this is. So very different from enterprise applications. Our sort of customers or stakeholders are primarily faculty researchers, research groups, and also the agencies that funds these research programs. And the business model traditionally, it's all grant-based. So that brings some, challenges that you don't have the capacity when you need it, right? So that's something that we want to find ways to improve. And perhaps maybe the main challenge, main characteristics of RSE is that, remember that definition, research and programming. So these are people who not only have deep skills in advanced computing and data technologies, programming skills, software design, and all of that good stuff. They need to be intimately familiar with research process to be able to speak languages that researchers understand. And so some of these RSEs come from domain science, some from computer science. So these are people who are, more or less flexible. They can, try to fit in a research team, try to understand and translate. I think one of the major challenges is to translate researcher ideas into something that you can implement and support in long run in a software product. So some of the things I thought, I can show that, the roles of RSEs within RCAC, there are internal projects that we do to improve the operations of the center, to improve user support, to improve training, and also bring system components together to integrate them. And externally, we sort of kind of like a consulting house, right? So we talk to people, consult them on, if they're ready to put in a proposal, we can come in and discuss what they want, what they need, and come up with a cyber infrastructure solution. So all of those things we do, these things are very often interchangeable. By that I mean, you originally develop something for internal use, but it actually has wings and becomes something that you can use for research projects. We actually are working on things like that right now. So, so these are examples, but I don't mean to go through the list. Just to say that, amongst our projects, some are, we call grant funded, meaning that we partner with faculty, with research groups, with outside partners to write the grant together, to do the design up front so we know what it will cost. And so when we're funded, we go in and implement that. And then there are the second category is people got their grant and they come to us say, now we need to develop this, and can you help us? And then there's also the third one, which is very important, but right now it's not well funded, is the exploration. So we always have new ideas, and when we see real drivers from faculty research, then we can maybe bring those forward. But we have to do some prototyping, do exploration ahead of time. And when can we do that, and how are we going to fund that? So that is one of the challenge for us to scale up to be able to support some of the larger initiatives. So just to give people an idea, kind of the size of the projects that we're doing. So on average, we were exceeding $2 million in research expenditures each year. And also take an example of last year. I know entire RCAC has more proposals, but I think at least 12 or maybe more proposals that we partnered on has significant RSE components. The tools we built, I thought, we got way too many things to list. So I'll just pick a few just to highlight the kind of tools we develop and give people a sense how we kind of keep moving forward with those. So one is this extensible geospatial data framework where we abstract the process of acquiring data from distributed remote data repositories and extract the process of processing data, whether it's pre-processing or actually doing the modeling. We abstract those steps out to create a framework to so that people can create their own data connectors, data processors, and then to be able to put them together as a full workflow. And these are open to communities to contribute and to use. So this is one of our very large software projects that's been going on for 5 years. The next thing I want to highlight is, sometimes these projects come out with, become a resource to students and to people who are, wants to get into maybe cybersecurity field. So this was a project called Cheese. We partner with Professor Baijian Yang in Polytechnique. And so we created a platform where you can see the little blocks. These are different lessons that people can use. It's right out of the box. And if you're curious on learning some of the techniques, like hacking and, more to learn it to prevent that. So that's something that came out of these projects. It's a very nice project, and I just run into Professor Young, and we said we should really continue to work on this and scale it up to be more broadly used. And the other thing I want to mention is this streaming data cyber infrastructure that we started with one project helping Dr. Jin in ABE to manage his sensor data when he creates these handheld sensors where researchers and eventually farmers can take to their fields and examine the health of their crops. And so out of that, we created this more abstract platform. We eventually named it Stream CI for managing streaming data. And it has been used in multiple projects, from small ones to large. For example, the ecology faculty, he's using sensors. Well, he has students who deploy sensors and collect data, and he doesn't need to do his own programming or set up his own cyber infrastructure. He can just say, here's my sensor data streams, and then once we turn on the faucet, students can use the data to do analysis. And more recently, it has been used in projects that deals with manufacturing machine data that keeps spitting out data streams. I actually have a video from our software engineer, Jay Wu. I'm not going to play it here. So as the 3D printer makes a part, the data comes out, and then we can see the data points coming up. So these are some of the applications. Of course, we also operate a Science Gateway, which is a portal accessible publicly. In this one in particular, I'm really proud because we're going on like the 8th year, I think. It's still going. And it's still going because we are supporting multiple projects, including some of the larger projects led by Purdue professors. And we're supporting simulation and geospatial data-driven tools on this platform, and people can publish their research objects, data sets, and tools, for example. And also we have this hosting model that seemed to be successful so far, that basically multiple projects share the cost of the hardware and support. That way, everybody can work together to keep it going. And so on this platform, we actually have approximately 10,000 users every year, and including, for example, students from a high school in Japan. Without us knowing, they've been using it during the pandemic to use the remote sensing imaging tool on here in their classroom. So we were very surprised to find out. We actually contacted the professor, and he said, well, he keeps using it, having the students do projects. let's see. Okay, so I don't know if this is the last thing, but there are also these more compact kind of, you call it web application, or things that we found more useful for data exploration. And also, the key point of this gateway in a container is that it's done in Jupyter notebooks. It has a nice user interface, and we turn it into a template. And so we can quickly develop these applications without having to redo all the stuff every time. And one very important point is tools like this can be maintained by research groups. So this is so far that we've found some groups that are able to do that. So this is another way of creating something by our well-seasoned software engineers, and then turn it over to the research groups so that they can keep it going. And then, of course, thanks to our campus cloud infrastructure, we can deploy it on there pretty easily. One thing I do want to highlight is, on the Envo project, even though it's primarily a systems project, we have our summer undergrad students that come in from different universities, not just Purdue, to work with. These are the 5 students that we hosted this summer. And even on a project like Envo, it's actually, there's a lot of research software engineering. So all these students, they worked on sort of more RC type projects during the summer, even though the target is to really improve Envo operations and make it easier for our end users. So I won't go into any details except to say that these are the type of projects that the students worked on this summer. For example, as I mentioned earlier, we want to be able to burst workload from our HPC side to Azure cloud, or from our composable subsystem to the Azure cloud. And so these 2 projects are worked on those 2 aspects. And then we have another project working really on understanding the user applications, what they're using, what's popular, what are some potential issues. So you can see, actually the student came up with a really nice dashboard. And then another student worked on things like how do you make Jupyter notebooks, Jupyter notebooks, right? Yeah, easier to start. Kind of like he had something on his slide, easy button. So it's like, we get a lot of complaints saying, well, you have Gedit, you have Envo composables, but I don't know how to use it. So we want to provide that easy button for people to just click and get their Jupyter environment right away. So there are obviously challenges. I think for us, the first probably is the broader awareness of RSC, both in concept and also in understanding what we can do. And business model, as I mentioned, there are still challenges to work through. And of course, the technical aspect, technology evolves constantly. How do we keep up? How do we pay our so-called technical debts, right? So if your system has been, 8 years old, and probably some things will not work. Or if open source stuff suddenly disappeared, what do you do? Or if Google start charging. So all of those things are kind of fall into the realm of RSE. And of course, our number 1 concern is people. So talent recruiting is challenging, to say the least. And also, is there a clear professional path for growing, within the profession? That's unclear, although there are a lot of work ongoing right now to establish that, and we hope, raising the awareness within the university. And we also work with HR to, kind of define more clearly, where the path is for these talents. And so I'm sure there are other things you can think of. We would love to hear your thoughts about, how we can grow this program. Okay, so I do want to give a shout out to our communications group. They've been wonderful putting out articles, and if you want to learn more about RSE at RCAC, I would encourage you to look at our annual report. And also the RCAC website has a lot of wonderful science stories that have been written up about how users, a lot more details, how users use our resources and how we partner with researchers at Purdue and also at other universities. And that's all I have. So I'll be happy to answer questions.
So I'd like to say this is a great presentation because the RSC role is a growing role within the industry, especially with companies like mine, like Lilly, where we're looking for that specific type of skill sets to help process innovation with automation and whatnot. And we have a lot of aging systems, a lot of legacy systems that need to be updated. The problem is that we have to integrate and transition between older archaic processes, business processes, into something that uses the more recent technology. IT cannot work hard enough or fast enough to get that moving because it's all done in parallel to current business as well as the new technology. And I think the RSE role has the right skill sets because they can understand the problem, they work with the business to understand what those business cases are, but have the IT background and technology to understand how to apply it in real time. So I'd have to say, if you want justification, go to industry because there's plenty. I can't ask for enough people with those types of skill sets to make an organization as big as mine to catch up, because we're going to fall behind in technology, we're going to fall behind in resource management, and we're going to fall behind in innovation in general if we're not able to take what the new software platforms are, and it seems like they're turning everything around every 1 to 2 years. You just can't keep up. So I want to say big support for the RSE role, and there's going to be a huge demand for that, especially as bigger companies grow. They're just not going to keep up with technology.
May I ask what company do you represent?
Oh, Eli Lilly.
Oh, okay, great. Thank you. Thank you for that, sort of endorsement. I don't know if I should feel relieved or worried. Yeah, absolutely. I think that role, right? So we all have these problems, and we actually went through a lot of that. We have our scientists and engineers, written the same software 3 times or even 4 times, right? Just because the requirements are evolving, people want bigger and more scalable things, and also technology is moving. So yeah, absolutely. I think if there are ways for us to work with the industry, I'm all ears to that.
Well, the career path is awesome. I mean,
Great.
You can really
That's
define
a
this
point.
as a true career path.
Yeah.
And the exact skill sets are the ones that you just named out. So.
Great. Thank you.
Any other questions? Do you have any advice for any companies that might want to get involved, or how a student can become an RU student?
Great question. So we constantly look for great students. So if students are interested in whether you're undergrad or graduate student, come talk to us. We do have structured programs, both for the HPC side, so we're always open to talk to students to see if the interests match. And we do, for ENVO, we do we do plan on having the next program for next summer. So I think you should look out for the announcement to put in applications.
So you're saying that a student can have access to a top 100 fastest computer in the world here at Purdue University?
Who wouldn't want to, right?
Excellent. Thank you very much. Thank you very much, Carol.